We are doing more root functions, except today we're talking about non-rigid transformations. Everything we did yesterday had to do with simply taking something and sliding it left or right, or moving it up or down, maybe even flipping it horizontally or vertically. All those same things still apply today, except today we're actually dealing with non-rigid transformations, which take a shape and stretch it taller or maybe shrink it. So it's stretching and shrinking that shape that we're starting with. So just as a little reminder, y equals the square root of x. What shape is that? Swoop. Swoop. Very good. And y equals the cube root of x. What shape is that function? The wave. My breaking wave. Me surfing on that breaking wave. Okay. Today we're dealing with multiplying. Okay. Multiplying, and we want to pay attention to whether we're going to be multiplying the x value or the y value, the x coordinate or the y coordinate. So pay attention. We're going to be labeling ordered pairs today, and you want to do the same thing. Label those ordered pairs, write out phrases, circle them so that you know what and why we're doing stuff. Example 1, graph the function by transforming the parent graph. Graph the function by transforming the parent graph. And again, I will just remind you that starting next week I will be grading notes. Get another participation grade in the book. And know that for Christmas, you should ask for new notebooks. And we're going to institute the 2-notebook policy next semester. 1 notebook just for class notes, just for these notes, and another notebook just for practice. Okay? I want you to be able to keep your notes open and work on other stuff, work on the practice assignment while you don't have to flip back and forth. That's the goal. All right. Here we go. How many transformations do you see in this function here? How many changes? What are 3 things that are oh, damn it, I just gave you the answer.
I think there's 3 things.
I think there's 3 things. Okay. I hate when I do that. Okay. Let's talk about the ones that we know. What does this one do?
Flips it upside down.
Okay, so that is a vertical reflection. Very good. It's -1 times the graph. This causes a vertical reflection. Okay, so we did that yesterday. And we also have this subtract 4. What does this subtract 4 do? Moves it down 4. Good. This 4 is on the outside of our little root function here. And so it does move it down 4. Okay, good. This is a new one. This says we have 1/4 times x. So this is another product one, okay? But it is much more complicated. So let's start with our parent shape, and I'll talk about what's going on in just a second. What is our parent function here? What is our basic shape? Swoop. Yes, it is the square root of x swoop graph. So let's start by making a little sketch of that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And my little swoop graph passes through 0, 0, 1, 1, and 4, 2. So there is my parent graph. And again, Delta Math gives that to you, but we want to have it in our notes. And know that it passes through the point 0, 0, 1, 1, and 4, 2. And I'm writing those on purpose, and you should too. Now, let's talk about this transformation here. we're going to do them in steps. This transformation, this 1/4, is it inside or outside? It's inside with x, right? So that 1/4 is definitely going to affect the x values. And that's really important to understand. And remember, everything with x is always opposite what we think it does. Everything with x is always inverted. It's always different, okay? And so when we say 1/4 times the x's, we have to invert that. We have to flip that. And it's actually, instead of 1/4, we're going to do 4 times the x values. And that is really important. It is 4 times the x value, or 4 times the x coordinate. And that's very important. Over here, we have this vertical reflection. We said that that was a number on the outside of the function, so it is affecting y values. That vertical reflection actually says we're going to take -1 and multiply it to the y value, or the y coordinate. So we want to pay attention to what's happening to the x and y values on today's lesson. So we're going to take our x value, we're going to multiply it by 4, we're going to take our y value, we're going to multiply those by -1, and eventually we'll do this down 4 shift. Why do we do these pink things first? Because they're multiplying our values, okay? Remember, everything with x gets flipped. Weird, okay? Let's think here. If I have the point 1, 1, and I'm going to multiply the y value by -1, what does that ordered pair turn into? 1, -1. It flips right down there. 1, -1. And then if I multiply the x value by 4, what does it turn into? Yeah. So you can think here, I'm going to times by -1, and I'm going to times the x coordinate by 4. So it becomes 4, -1. That is the new point there, and I would do that all in one step, frankly. This is really useful. I'm just taking my x value, and we're going to multiply it by 4. I'm taking my y coordinate, we're going to multiply it by -1. And if we do that, we get this new point. This other point here, if I'm going to multiply the x value by 4 and the y value by -1, times by 4 times by -1, that new point turns into what? 16, -2. Huge! Way over here, 16, -2. Obviously, I'm not going to graph that one. Okay. But you can see what happened. Our graph just went all crazy. Like, what did it do? What is the effect that our transformations caused to this graph? It stretched it. Yeah. This would be a horizontal stretch because we're multiplying by 4. It's taking it and making it longer horizontally. All right? Very interesting. Now, from here, we can do any adding or subtracting. So I'm going to take my point here at 0, 0, and we're going to go down 4. And that's going to take this whole shape and just slide it down 4. 1, 2, 3, 4. This other point would come down 1, 2, 3, 4 as well. And we get this very stretched out square root swoop shape. Okay? And there is our final graph right there. Okay, so on Delta Math, you would have to take this point at 1, 1 and slide it, drag it to get this point 4, 1. So it is important to look at the points. Maybe write down the points and do this little times by 4, times by -1. Okay. Let's try another one here. Letter B. We have y equals the square root of 4x plus 5. What is our parent graph? Swoop, square root of x, swoop, very good. So I'm going to start with that. 1, 2, 3, 4, 5. 1, 2, 3. I have to make that a little bigger. 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Square root swoop passes through 0, 0, 1, 1, and 4, 2. And I want to label those ordered pairs. I have the point 1, 1, and I have the point 4, 2. That way we can see what's happening to those ordered pairs. All right, how many transformations do we have? 2. All right, so first we have this 4x, 4 times x. And what do you think that's going to do to our curve here? Make it smaller. That's exactly right. Is it affecting x's or y's? X values, good, because it's inside with x. It has to affect the x values, inside with x. And we're not multiplying by 4. What are we multiplying by? 1/4. That's exactly right. 1/4 times x. And that's really important. We always sort of invert everything with x. It's never what it looks like. It always is harder. And then we have this plus 5. Is that inside or outside? Outside. So the plus 5 affects the y values, vertical things. So this is making us go up 5. Okay, now here's on Delta Math where it gets a little bit tricky. If I were to take this point 1, 1 and multiply the x value by 1/4, what would it give me? 1/4 1. So it slides in. Delta Math is not going to let you graph that because it's not a nice whole number, not an integer, okay, because it's a fraction. But we can take this point and multiply it by 1/4. What is 4 times 1/4? 2. 2? 1, 2. There we go. Okay. 1/4 of 4 is 1. 4 times 1/4 is 1. So this turns into the point 1, 2. So I'm just going to erase that. And that's the point we're going to move. It comes right here and becomes a 1, 2. And you can see it got, woo, it moved, it went that way. And now we've got this weird smushy square root graph. What would you call that? Shrink, yeah. It is a horizontal shrink. I also like the name horizontal compression, like a spring, okay? It's being compressed back towards the y-axis, okay? It's just smushing, compressing. So this is called a horizontal shrink or horizontal compression. And from there, I can now shift my graph up 5. So I'm going to take this point and go up 1, 2, 3, 4, 5. And my point at 1, 2 and go 1, 2, 3, 4, 5 will slide along for the ride. And there's our final shrunken curve. Okay. I really like Delta Math for how it has you do this. I think it's really quite cool. All right, questions on these two? It's hard to read for me. I don't know what's up with my screen. It's very dim. All right, just a couple more. Those are the hard ones. These are the easy ones. Y equals 4 times the cube root of x plus 2. What is our parent graph here? Wave. Good. That's the cube root of x. That's our wave function. Very good. I love our little common lingo we've got going on. I think that when my students move to other teachers, I get really embarrassed because you guys will say stuff like, that's the wave. And the other teacher's going to be like, say what? It's cube root function. Or like, it could be like, that's the swoop. And they're like, what? Yeah. Yeah. Wait, say it again?
Can you go back?
Oh, go back. I'm sorry. Yeah. Good? Okay. All right. So I'm going to plot a couple of those points. There's 3 lines, 3 points on that diagonal there, 0, 0, 1, 1, and -1, -1. And I'm going to go ahead and label those. Not 0, 0, though. And 1, 1. And then it's that nice little breaking wave. I love. Okay. I think we said we have 2 transformations here. This is 4 times our function. What is that 4 going to do to our curve? Is it inside or outside?
It's outside.
Outside. Does that affect x values or y values?
Y values.
Y values. Outside always affects y values. And it's saying 4 times those y values. And it's outside. It's straight up legit. It does exactly what it says it's going to do. No messing around with it at all. Okay, y values are easy. All right, so that is going to take my y values and multiply them by 4. So I'm going to just write that down. This is going to times that y value by 4. And it's going to times this y value by 4. All right. And then, what does x plus 2 do to our curve? Yeah.
So on the wave, because like on the swoop one, when it was 1/4, it was times it by 4, but when it was 4, it was like multiplying by 1/4. So on the wave, is it if it's 4, then you multiply it still by 4, or you do 1/4?
So because it's affecting the y values, you do exactly what it looks like.
Okay.
If it was affecting the x values, it's always wrong.
Okay.
It's always flipped.
Thank you.
Yeah. What does x plus 2 do to this curve?
Right, by 2.
Almost. Left
Left.
2 units. And again, that's something you want to write down. That is a plus or minus. That is sliding our graph up, down, left, or right. Products are stretching or shrinking. So let's see what happens here. First, we have to do this multiplication. So if I have the point 1, 1, what does that point transform into? 1, 4. 1, 2, 3, 4. It stretches up taller vertically and becomes the point 1, 4. And if I have this point -1, -1, what's it going to turn into? -1, -4. And the nice thing about delta math is it'll do it at the same time. -1, -4. But I think it's worth writing down. 0, 0 doesn't move. 0, 0 doesn't move because if you take the y value of 0 and multiply by 4, it stays exactly where it is. All right, so this gets much taller. It's very cool. That is, a tsunami now. Okay. All right, so we've got our very much stretched out wave, and then we can shift it left 2 units. So I'm going to take my point at the origin and go left 2 units. And these other points will come along for the ride as well and also move left 2 units. And my tsunami just moves along. Very fun. That final one there. Big giant wave. That's a roller coaster right there. Like that. Okay. All right. Ladies and gentlemen, if you're unsure, what can you do? Graph it out. Please don't forget. I don't want you to get these wrong on the test. Like, there's absolutely no reason to get them wrong on the test, right? Do your best guess. Make your choices and then confirm on a calculator. All right. Last one here, ladies and gentlemen. Y equals 1/2 times the cube root of -x plus 3. What is our parent function here? Cube root again. Our wave function. Cube root wave. 1, 2, 3, 4. I have to go all the way to 8, I believe. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Howdy. All right. Again, we've got some points in a row, and on this one, I've got my 3 dots in a row, but I also have 8, 1, 2, 3, 4, 5, 6, 7, 8, 2 as a point on the graph. I'm going to label that one 8, 2, and negative 8, negative 2, negative 8, negative 2 on that wave function. Okay, so there's our starting graph. How many transformations do we have on this function?
3.
3, yeah. We've got a times by 1/2. This is negative 1 times x, negative 1 times x, and then we have a plus 3, so we have 3 transformations. What does the plus 3 do?
Moves it up 3.
Up 3. Good. It's on the outside. That's going up and down. All right. This 1/2, is it on the inside or outside? It's on the outside, so does it affect x's or y values? Y values. What's it going to do to the y values? Multiply by 1/2. 1/2 times the y values. Write that down. That's useful information. Then I have this negative 1 times x. Is it affecting x values or y values? X values. It's inside with x. It must affect the x values. And what's it going to do to those x values? Multiply them by negative 1. Yeah. You can think about everything with x is always inverted. We'd have to flip it upside down. But if you take negative 1 over 1 and flip it, isn't it still just negative 1? Yeah? Okay. So it does just multiply the x values by negative 1. But we are sort of kind of flipping it. That is simply a horizontal reflection over the y-axis. But we can just do it on the points. I might want to use 1, 1 here. But if I take my y-coordinate and multiply it by 1/2, what is that point? 0.5. Yeah, it's 1/2, and we can't plot that using delta math. They want you to plot it on nice integers. So that's why I'm using this point. So we are going to take that y value and multiply it by 1/2, and I'm taking the x coordinate and multiplying it by negative 1. So if I take that 0.82, multiply by negative 1 and 1/2 for the y, what does it turn into? Negative 8, 1. Good. Negative 8, 1 is right here. Negative 8, 1. 8 times negative 1 is negative 8. 2 times 1/2, or half of 2, is 1. This is causing my graph to shrink vertically and flip over. If I take my point down here at negative 8, negative 2, and multiply the x by negative 1, and multiply the y by 1/2, what does that point turn into? Positive 8, negative 1. Positive 8, negative 1. And 0, 0 stays exactly where it is. So we get this wave that is now flipped around and a little smaller, shrunk down some vertically. All right, from there, we get to move up 3. So I'm going to take my point at 0, 0 and move up 1, up 2, up 3. And that'll slide the whole shape up 3 units. And there is our final graph in red right there. Okie dokie. Raise your hand if you think you get it. Good. What do you have to do with y values? Anything in particular, or is it all good? It's pretty much exactly what it is, right? But with x's, everything is
Flip.
flipped. Everything is just weird. Okay? All right, ladies and gentlemen, go have at it.